Hi class, today we're going to learn section 2.8 implicit differentiation. We learned how to differentiate functions, um, means functions like y equals something with x, means y expressed only in terms of x, which means explicitly. Leave this topic for a moment. We learned how to differentiate functions like y equals x square plus 2x minus 2, something like this. Means now here the function y is expressed only in terms of x, means this expression is solved for y is isolated on one side. There it's easy. If you differentiate this with respect to x, we get differentiate this nx n minus rule. Remember, 2x 2 minus 1, which is 1, plus 2x to the power 1, so 1x 1 minus 1, which is 0, which is 2, right? Constant derivative of constant is 0. Now this is how we differentiate explicitly, means when y is expressed explicitly in terms of x, we know how to differentiate. Now let's see what this implicit differentiation means. If the y is expressed implicitly, which means you cannot solve the equation for y. For example, this is implicit, this is explicit, implicit, what we're going to learn today. If you get a function like x plus y equals to y square minus xy plus 1, so here x and y mixed in this equation. Now if we want to find dy dx, means the derivative of y with respect to x, dy dx, can we solve this for y? We cannot, but still we can differentiate this, right? Let's see how. Now explicit, we know how to do it. Let's get a simple example. Say if you want to differentiate y to the power, say 6 with respect to x. Let's see how to differentiate this. Now y, given y is a function of x, right, where y is a function of x. Now we know from chain rule we can write this as, since y we cannot differentiate with respect to x, first we differentiate this function y to the power 6 with respect to y, means we do dy to the 6 over dy, then multiply this with y with respect to x, right? This is from chain rule. Remember, at the time I teach you chain rule. I said it is just like dy to dy cancel out, we get dy 6 over dx, the same thing given. It is just like that, but it is not cancelling. This is called chain rule, right? So we going to use this. In fact, when we differentiate or when we find in derivative, our purpose is to find the slope of a line, marginal function of any marginal cost function, profit, etc., or rate of change. Means find the, given the distance function, find the velocity or acceleration, something like that. So in any case, it doesn't matter if we find derivative in terms of x and y. What I mean is, so far we get dy dx something like 2x plus 1, something like this. But it is okay if we get an expression for dy dx something like 2x plus y, 2x plus y. See, dy dx, when we find dy dx, we have both x and y. That is fine. Why? We want to find derivative at a particular point, so we have x and y coordinates, so we can substitute here and find the derivative at that point, right? Let's do an example. X equals y cubed plus y plus 1. We want to find dy dx. What we want to find dy dx. Given x equals this, right? So what we do is we differentiate this implicitly. We should not try, maybe we can solve this for y, but if we can differentiate this equation more easily than solving this for y, that would be fine. So this is how we differentiate implicitly. We differentiate with respect to x. When we differentiate x with respect to x is 1, right? Now when we differentiate y cubed with respect to y, you remember chain rule? I remind you one more time. When you want to differentiate y cubed, this is same as dy cubed over dy multiplied by dy dx. Dy cubed over dx is equal to dy cubed, we differentiate with respect to y, then we multiply that with dy dx, y differentiated with respect to x, right? Chain rule. Now this is exactly what we using here. So when we differentiate this, we get, now when we differentiate this, what we get? 3y square. 3 comes to the front, nxn minus 1. 3 minus 1 is 2. Multiply this with dy dx. Right? Therefore, that's exactly what we get here. So, do we have to do this on the side? Not really. When you getting used to do it, this is not hard. So this is what first we use the power rule, nxn minus 1, 3y, 3 minus 1 is 2, multiply by dy dx according to this, but you don't have to write this. With respect to y it is this, multiply this with dy dx, plus y with respect to x is dy dx. Differential, the derivative of 1 is a constant, therefore it is 0. You don't have to write 0, but I wrote it. Right? Now that's it, the differentiation. Now what we want to find dy dx, therefore solve this equation for dy dx. That's it. So keep this 1, take dy dx common factor, (3y square plus 1). Right? Then divide both sides by 3y square plus 1. We get dy dx 1 over 3y square plus 1. Right? That's our answer to the question dy dx. Get it? Let's see another example from book. Okay, let's do this example. I'm gonna erase this. Second example. Given the equation x cubed plus 3y5, I write the equation here. Plus 2x equal to 3y7 plus 2x square plus 4. Okay, given this equation, determine the equation of the tangent line to the curve defined by this equation at the point 2, 1. You understand the question? The shape of this curve. Don't worry about the shape, it could be anything, just assume it is like this, who knows. And they give us a point at 2, 1. At this point, tangent line at this point. Say 2, 1 is this point. This is the tangent line to the curve at this point 2, 1. This is the equation of this line. Use a different color. This is the equation of this. We want to find the equation of this line at 2, 1, right? So this is the method. The slope of the curve, okay, remember at the time we do equation of line, this question I ask you frequently. To write the equation of a straight line, we need two things: the slope and coordinates of one point. Now coordinates of one point, it is given. Now the only thing we need is the slope of this straight line. How we find that? If we could find the derivative of this curve, the general equation means it gives us slope at anywhere, then we can substitute these coordinates in that general solution for the derivative and find the slope at this particular point. You understand what I mean? If we could find the slope of this curve at this point, so the slope of this curve at this point is same as the slope of this tangent line, then we have that slope, say m, and we have coordinates of one point, we can write the equation of line. Okay, now what we got to do? Find the slope of this equation, right? For that, let's differentiate this implicitly. Means we cannot separate x and y. We cannot solve this equation for y. So maybe we can, but it is easy to do implicit differentiation and find dy dx. This one is 3x square. Remember, we differentiate with respect to x. With respect to x, 5 comes to the front, so we get 15 y to the power 5 minus 1 is 4. Multiply this with derivative of y, which is dy dx, plus the derivative of 2x is 2, equal to derivative of this is 7 comes to front, 7 times 3 is 21, y to the power 7 minus 1 is 6. So 21 y to the 6 times dy dx plus derivative of 2x square is 4x. Derivative of this is 0. Right? You don't have to write it. Now we want to find dy dx at this particular point. For that, this is the thing. Either we can move these dy dx terms to the left and isolate dy dx on the left side and move everything to the other side, or we can substitute these coordinates for x and y and find dy dx. Either way, it's the same thing. So if you substitute it here, your x is 2, this is your x, and this is your y. X is 2. 3 times 2 square plus 15 times y is 1, 1 to the power 4 dy dx plus 2 equal to 21 y to the power 6, 1 to the power 6 dy dx plus 4 times 2. Here we get 2 square is 4, 4 times 3 is 12 15 dy dx plus 2 equal to 21 dy dx plus 4 times 2 8. If you move this to this side and take dy dx out, we get dy dx times, here we get 15. When you move this to the other side, minus 21 equal to, have 8 here, 12 plus 2 is 14, we get minus 14. Here we get negative 6, therefore dy dx equal to, here we get negative 6, here we get negative 6 divided by negative 6 equal to 1. Right, so we get dy dx equal to 1. Now that's dy dx. Now we want to, now this is the slope at 2 comma 1. This is the slope m. Right. Then what we do, we want to find the equation of line. Two comma 1, this is x and y, m equals to 1. What we use? We use point slope form of the equation of line y minus y1 equals m x minus x1, y minus 1 equal to m is 1, x minus x1 is 2. I got m equals 1 here, so I'm erasing this. So we get y equal to x negative 2 positive 1 is negative 1. Y equals to x minus 1 is the tangent line to this curve at 2 comma 1. Okay, that's the answer. This is the answer. Right. I have a word about this notation. I'm gonna erase this. For dy dx, as expressions get complicated, there may be many dy dx's appear, and it might be convenient if we use dy dx as y prime or y dash. Right. This is what I mean. I'm just showing you. Here when we differentiate, I get 3x square plus, here we get 15 y to the 4 y prime, here we get 2 equal to 21 y to the 6 y prime dy dx plus 4x to the 1. Right. So that might be convenient. When we have big terms, it looks complicated, isn't it? Now we can solve this. If the question asking you to find the derivative, no tangent line, nothing, know this part. I'm just showing this as a separate example. If the question just asking you to find the derivative, you move y, those terms with y prime to the left, this one and this one, then we get and let's take out. Okay, let's do it one more step. 15 y to the 4 y prime minus 21 y to the 6 y prime equals to 4x minus 3x square. Then take out the common factor y prime, because we want to solve this for y prime. We get 15 y to the 4 minus 21 y to the 6 equal to, leave it as it is, 4x minus 3x square. Then divide both sides with this factor. We get y prime equals to 4x minus 3x square divided by 15 y to the 4 minus 21 y to the 6. So this is the general expression for y prime, or dy by dx, or the slope of the curve. General equation for the slope of this curve. We can use this to find slope of this curve at any point. In this question it is given 2.2 comma 1. If you substitute 2 comma 1 here, you get the same answer that we got before. If the question asking you to find a slope at a different point, substitute those x and y coordinates here, we get the answer for the slope at that particular point. Right? Okay. I'm going to erase this. You may use this as different example, say question number 3. Find dy dx or say y prime. Same thing, right? Let's do another example. I'm gonna erase this. Find y prime. Now you know what y prime means, the derivative. Y prime if this is the equation given 3x square y4 minus 2x square plus 3y to the 5 equal to 17. Right, now let's see how to do this differentiation. Okay, here y prime means, I write it on the side, y prime means dy dx, right? So what this means is we have to differentiate this with respect to x. Okay, now when we differentiate in this, you see now this is a product. Okay, let's analyze this. It has a constant, it has x, it has y. So we can look at this expression. Don't worry about the other part. We can look at this part as constant time x squared times y to the power 4. Means, first of all, we can look at this as 3 times this. Agree? 3 times this. Now that means look, when we have, I'm just writing something else, 2x to the power 4, no matter what, this 2 comes to the front, 2 comes, then we differentiate only this part, we get 4x cubed, right? So this 2 stays in front. So we know here in this case 3 stays here in front, and we have to multiply that 3 with derivative of x square y to the power 4. Now if you look at this part, x square y to the power 4, it is a product between two things, x square and y to the power 4. Product between two things. Therefore we have to use the product rule there. Okay, let's do that. 3 stays outside, and in parentheses I'm gonna write the derivative of this. For that I'm gonna use the product rule. If I remind you a little bit, the product rule, uv prime, the derivative of uv, the product, equal to uv prime plus v u prime, right? Remember these formulas: product rule, quotient rule, right? Now this is u and this is our v. U times v prime, x square times derivative of y to the 4 is, with respect to x, is 4x 4y. Four y to the 4 minus 1 is 3 times y prime, then plus this part, plus y to the power 4 times derivative of u, which is x square, this is x square, this is x square is u, y to the power 4 is v. Y to the power 4 times derivative of u, which is multiplied by 2x, right? Now that's it, that's the derivative of this. So I close parenthesis, so that multiply by 3. Now the derivative of 2x square, it's only single variable there, so we can use the power rule, and x n minus 1, we get 4x to the 1. Here we learn this, how to do it. Plus 5 times 3 is 15, y to the power 5 minus 1 is 4, equal to the derivative of 17 is 0 because it's a constant. There's this product rule, simplify this. Let's distribute this first. 3x square when we multiply these two terms, 3 times 4 is 12, 12x square y cube y prime plus 3 times this is equal to 3 times 2 is 6 x y to the power 4 minus 4x. Oh, here we have to use something else. 5y to the 4 times we have to multiply the derivative of y times y prime, chain rule, y prime equal to 0, right? 4x plus 15 y to the 4 y prime equal to 0. Now we have y prime in two places here, here and here. From these two, let's take y prime out. Y prime 12x square y to the power 3 plus 15 y to the power 4. We can move these two terms to the other side, then it is 4x minus 6x y to the 4. Then we get y prime equals to 4x minus 6x y to the 4, means divide by this factor both sides of the equation. Divide by 12x square y cube plus 15 y to the power 4. Right? That's the answer. Okay, this is the y prime. I erase this. Okay, 5. The equation x square plus p square equals 25 represents demand equation. Okay, I write the equation. I use simple P. In demand equation we know this is number of items and P is the price. P square equal to 25. It is given in this question. Demand equation when X and P are H in the first quadrant. X and P are H in the first quadrant means they both positive. We know number of items or price, they cannot be negative, therefore they both positive, so it is in first quadrant. Then find dp dx. We want to find dp dx. That's part A. Okay. For that, to find dp dx, let's differentiate this equation with respect to x. We get 2x plus, first differentiate with respect to p, we get 2p times dp dx means p prime. Let's write dp dx equal to 0. Now if you divide whole equation by 2, these 2 cancel out and we get dp dx equal to negative x over p. Move this x to the other side, then divide both sides by p. We get negative x over p. Part B. Part B is find dx dp. We found dp dx. Here they are asking you to find dx dt. Now here we can do this quite easily without doing anything. We can, this the reciprocal of this, and we dx dp is same as 1 over dp dx 1 divided by dp dx. So let's substitute from the previous part. 1 divided by dp dx is negative x over p. 1 divided by negative x over p is same as negative p over x. Right? I use this for simple p. That means if you want dp dx, if you find dp dx, we can find dx dp just by the reciprocal of this. You see, negative x over p becomes negative p over x. Now assume we don't know this. Assume we don't know dx dp equal to 1 over dp dx, and assuming that, let's try to differentiate this and get the answer. Means we know the answer is this, but let's see if we get the same thing by differentiating. Now we want to differentiate this with respect to p. We get 2x dx dp plus, here we get 2p equal to 0. This is the answer let's see if we get this. 2 cancels out, we get dx dp is equal to, move this p to the other side, negative p over x. We get the same answer. In this case, the equation is not too complicated. Simplification is not hard. It's not a big deal. We differentiate this. But in case if you get a complicated equation, and if you ask to find both dp dx and dx dp, you can use the property I just told you. Just get the reciprocal. Right. Part C. dr dx. I erase this. Part C. We want to find dr dx. Okay, R is the revenue. We know R equals to x times demand function, x times number of items times the demand. So let's differentiate with respect to x. We want to differentiate R with respect to x. dr dx equal to, we again use the same product rule. This is a product between two things, u times v prime plus v u prime, x times derivative of p dp dx plus p times derivative of x with respect to x, which is 1. Now this is dr dx. In previous part we found dp dx. dp dx is negative x over p. Substitute for this part. This is equal to negative x square over p plus p. This is the answer. Now we can get these two terms to the same denominator by multiplying the second term by p and p. Then we get, let's write the positive term first. Not a rule, I'm just writing p square minus x square over p. Okay, now part D, dr dp. I'm gonna erase this. We want to find dr dp. R is same thing, x times p equal to, again product rule, u times derivative of v. This is u, this is v. Derivative of p is with respect to p is 1 plus p times derivative of x dx over dp. Okay, here we get x plus p. We found dx dp before. Dx dp is negative p over x. Multiply top and the bottom by x here, multiply by x and x. Here you have 1 in the denominator. Write it here, x square over x square minus p square over x. Right? So x square minus p square over x. Alright, that's all for section 2.8. right? I keep telling you, do these questions by yourself, right? Take care then.